Assalamu alaikum dear students. Our next topic is refraction of light through a prism. It can also be treated as a practical, but right now we are going to just consider its physical properties. Okay, so first we shall consider a prism here. A prism is a transparent optical element having at least two flat, polished surfaces which have an angle between them. Okay, so prism are used to refract light basically. So prism are of different shapes and kinds, but usually in the lab we use a triangular prism like this one, the one I have drawn here. This is a triangular prism whose two faces are of a triangular shape. The dotted lines show the edges of the prism which are behind it. Okay, so basically it has two triangular surfaces and three rectangular surfaces. You can see one rectangle here, one rectangle is behind this rectangle, and one is at the bottom. Alright, so prism is basically a glass kind of a slab. You can say you have used slab before, but now we're going to use triangular shaped glass for the refraction of light. Okay, so what are we gonna do now? There are two types of phenomena that occur with a prism when light actually falls on a prism. Okay, the first one is deviation of light through a prism. So what is deviation? It is defined as the change in direction of light ray when it leaves the prism. It's called the deviation through prism. Okay, now let's consider this diagram here. Here we have one face of the prism, and this one shown with the black one, is the incident light. Okay, it falls on the surface of the prism. This dotted line shown in red color is the normal. You can see this makes an angle of 90 degrees with the surface of the prism. When this light enters the prism, it definitely gets refracted, and you can see here this one is the green line. It gets refracted by some angle, and as the glass has a refractive index more than that of the air, so this green light will bend towards the normal. Okay, if this second medium has a higher density, so it has a higher refractive index. Okay, so it would bend towards the normal. Okay, so you can see it has bent a little. This dotted line shows the original path, and this one shows where the light goes after refraction. Now after refraction, when it strikes the other part of the prism, the other surface of the prism, what happens? It gets refracted again. But this time, notice that we've already studied that in case of a slab, when a light enters like this, it gets refracted like this. But again, when it leaves this glass slab, it follows its original direction. Okay, so the direction of incident light and the direction after it leaves the glass slab, these both directions are the same, although this is slightly deviated from its original path, but the direction stayed the same. But in case of prism, what happened? The incident direction of light was just shown by these dotted lines, but the final actual refracted ray was deviated from its original path. This is because in case of slab, both the surfaces of the slab were parallel to each other. But in case of prism, both the surfaces of the prism are not parallel to each other. They make an angle with one another. That's why the final refracted ray won't be in the same direction as the incident light. Right? Here, the green light, as it strikes the second surface, it gets refracted, and it gets refracted away from the normal. This one shown by the dotted line is the normal, and this light gets a bit just gets refracted away from the original path. Why does it get refracted away from the original path? Because the refractive index of the second medium in this case is air. The refractive medium of the refractive index of the second medium is very less than the medium from which the light was incident. In this case, the first medium was glass, and in this case, the second medium was air, which has a less dense, you can say, property, and has a less refractive index. Alright, so that's why it would get away from the normal. Okay, the more the refractive index, the closer to the normal. The less the refractive index, the away it would be from the normal. I've shown it like this. You can see this. Okay. If the density of second medium is from the up arrow shows that it is greater. The density of the second medium is greater, then refractive index of second medium would also be greater, and the deviation is towards normal. Okay, if densities of second medium, always remember this is for second medium. Okay, if density of second medium is greater, then refractive index is greater, and thus the deviation would be towards the normal. Similarly, if density of the second medium is less, then the refractive index of second medium would also be less, and thus the deviation is always away from the normal, just as you have seen in this case. Okay, I will have closer look on this. Okay, this was incident light. It got bent a little towards the normal because glass, which is the second medium, has a greater refractive index. Okay, so after traveling some time, okay, it just strikes the other surface of the prism and gets refracted again, but this time it won't get closer to the normal. It would get away from the normal because the second medium, which in this case is air, has a density less than that of the glass, so it would have a refractive index less than that of the glass. If the refractive index is less, so the ray would just travel away from the normal. Okay, in this way, the direction of the refracted light is not the same as that of the incident light, but it would be just somehow changed in this case. Second point is dispersion of light through prism. Okay, you can call this as an application of deviation of light. Okay, so what exactly is dispersion? The splitting of white light into its components through a prism is called dispersion of light through prism. Okay, so basically dispersion means splitting of light. All right, now in this case, here we had considered any kind of light, any incident light, but in this case we will specially consider white light. Although I have drawn it like with a black pen, of course I didn't have a white pen here. Okay, so but this black arrow indicates white light. Okay, when white light falls on a prism, what happens? Okay, here we will see that this white light will get split into its components. Okay, what are the components of white light? It has a red light, a yellow light, or an orange light, a green light, blue light, indigo light, and violet light. Okay, so these are the components of white light. white light is a combination of different wavelengths. Okay, so in this case, what happens when white light falls on a prism? All its colors get splitted. Okay, the one with the higher wavelength gets deviated the least, and the one with the least wavelength gets deviated the most, because wavelength is inversely proportional to deviation of light. The higher the wavelength, the less would be the deviation. The lower the wavelength, the more would be the deviation. So in this case, red light has a higher wavelength, and the violet light has a higher wavelength. So in this case, this was normal, and the glass had a refractive index more than that of the air. So obviously these two rays get bent towards the normal. Okay, of course, white and the red light would get bent a very little, and the violet light would get bent much more than that of the red light. Okay, so after reaching the second surfaces, now you can see there's no one light. Okay, there's not one ray, there are two different rays with different normals here, but these normal should be parallel to one another. Okay, after reaching these points, they will again get refracted from their original path, but again the angle of this refraction would be different. The red light gets refracted very little, and the violet light gets refracted much more than that of the red light. Okay, so now again consider this image. Okay, so what exactly is this angle called? The angle between the original direction and the change in direction. This angle is called angle of deviation, theta DEV. Alright, this is the angle through which the light got refracted from its original paths, from its original direction. You can just calculate this theta deviation with the Snell's law, which states that theta equals 2n2 divided by n1. So for both the surfaces, you can just calculate these theta deviation. Alright, just very simple thing. Okay, in this case, suppose if this was the original path, then the angle of deviation for the red light will be less than that of angle of deviation for violet light. Alright, why? Because red light has greater wavelength and violet light has less wavelength than the red light. Alright, so in this way I've just drawn these two rays. Actually they're not these two rays in the rainbow. They should be the red light, and after red light there should come a second orange light, then the yellow light, then the green, then blue, then indigo, and then the last one is the violet one. But it's just so difficult to just draw all these 7 colors here, so I have just drawn the boundary colors: the red light, which has the maximum wavelength, and the violet one, which has the minimum wavelength. Between these two lies the range of 7 colors. Right? So this was all in today's topic. Thank you so much, everyone.